So today we're going to be talking about lesson 1.3, which is measuring angles. And I want to start out with the standard. We're still working on Kentucky HSG1, know and apply precise definitions of the language of geometry. We've finished line segments and we're moving on to angles. So again, this standard is going to be partially assessed. And that's what you'll find with a lot of these standards. We'll talk about one particular part of a standard in one lesson. Will probably cover only partially the standard. And so knowing those standards is going to be really helpful because a lot of those goals are what you want to accomplish in this class. And it's going to be really helpful for knowing what types of questions you're going to be asked on the EOC. So the first thing we're going to talk about is an angle. And by definition, in this case, an angle is two rays with a common endpoint. So two rays with a common endpoint. And what you'll see down there is a few examples of how angles will show up. So the first angle, if it's only one single angle and there's not a large diagram like this, right? So you've got a bunch of different lines intersecting in different angles. But if there's only one angle like this, and the vertex, the turning point there, that sharp turn there, is labeled with a letter, you can refer to it as angle A, okay? But, or a second option would be if the angle on the interior is labeled with a number. So in this case, this is angle 1. So angle 1, oops, I erased it. You can refer to it as angle 1. And then in the case where we're talking about a very large diagram, it might be helpful to label it by 3 points, okay? So the point in between is talking about the angle in question. So in this case, I would call it angle TAC, and I'm mentioning that A is the vertex, so that's the turning point. So this is this angle piece, so TAC, so you can see that describing that angle. I could also call this angle CAT. Either one would be acceptable, and if you look over here, it's really helpful for diagrams like this, okay? So if I say angle CBJ, I'm talking about this angle here. But if I say CBA, that's a 180-degree angle. That's a straight line, okay? And it's especially helpful for like over here. If I say H, you have no idea which one I mean. You don't know if I mean GHF or if I mean FHJ or if I mean JH and whatever this part is, if there was a letter there. It's really confusing whenever a vertex has more than one angle that it's forming, okay? So this vertex has several angles forming. So the way that we kind of distinguish that is to pick 3 points and label that angle. So this is GHF, this part of the angle. DFE is this part of the angle, okay? Same thing going on here. I've got another angle here, DFJ. I've got EFH. So you've got several angles going on, and it's easier to kind of keep track of what you're doing if you know the different ways to label some of whatever geometric figure you're dealing with. So if I come back here, we're going to go over some more definitions. And we're going to talk about equal versus congruent. So let's say I have this figure, angle DOG. When you see an M beside an angle, that's talking about the measure, okay? So if you took a protractor and you put it up against this angle, it would measure 52 degrees. That's what this is saying. So the measure of an angle is different than the angle itself, okay? So let me kind of draw that over here. So the measure of angle DOG, so here's angle DOG, so D, O, G, right? So I've got two rays kind of forming there. I'm trying to draw this neat. Not perfect, but it happens. And it says there that this angle is 52 degrees. So the measure of angle DOG is equal to 52 degrees. That just means if I measure it with a protractor and you measure it with a protractor, we better get the same, close to the same answer. But angle DOG is referring to the entire angle. So that equals, whenever you say angle DOG, it's copying, give me this. You're saying that this is the angle that you're referring to. Okay? So you're literally referencing the entire thing. Okay? So you've got two equilateral triangles over here, and you've got two different cases here. So you've got the measure of angle A is equal to the measure of angle BCA. Okay? So what this is saying is if I have a triangle ABC like that, here's A, here's B, here's C. You're saying that the measure of angle A is equal to 70 degrees. So this is 70 degrees. And then it says the measure of angle BCA is equal to 70 degrees. Well, that just tells us that the measures of those two things are equal. So measurements can be equal. When we talk about congruency, right, if I have a different triangle over here that's very similar, call it ABC. And then if you take a look at this statement, it says triangle ABC is isosceles. Okay? So isosceles by definition means two things. So you might not remember this. Isosceles means the triangle has two sides. That's bad. Has two congruent sides. And two congruent base angles. Okay? So it's telling us that this measure is the same as this one, and this measure is the same as this one. Okay? So the two sides are the same length, and the two angles are the same length. That doesn't mean we know their measures. It means that if we measure those two things, if we measure the segments, BC and AB and BC, it means that if we measure these two things, they better be friggin' close. Same with these angles with the protractors. If these two base angles are congruent, that's telling me that they're the same value, but we may not know the measure. So when we put a protractor here, if I get a measurement over here, and I know that this triangle is isosceles, I better get the same measure over here. It's either that or I did something wrong, or it's not isosceles. And so you're going to see congruency statements. You're going to see a lot of stuff. So let's label these two. So if I call that angle 1 and angle 2, I know that angle 1 is congruent to angle 2. I haven't done any measuring. There's no measurement here. By definition, we know that those two angles are going to be congruent because by definition, the triangle was isosceles. So that's something interesting to think about. I'm going to do my best to do this next part. Let's take a look here. Estimate and measure angles using a protractor. So what you'll see is you'll see a small angle. and a big angle. And I'm just going to copy these roughly. And back over here. So I don't think I have a protractor, but what I do have is I have the ability to rotate this thing so I can find the degree measure. So what I can do is I can put my little ruler here right next to this angle, and I can rotate it up. So let me make sure I can do this right. Yeah. So I want to rotate this up, so I'm going to start it there. So that's 0 degrees. And then if I rotate this guy up, just continuing to keep that point on that angle, I can kind of measure this angle. So that angle is about 46 degrees. Okay? And then let's say I want to know what this one is over here. Well, what I'm going to do is I'm going to go to 90, because I know that that angle is more than 90 degrees. I'm going to put that little dot there, and I'm going to continue to rotate it. Make sure. So that's 0 degrees. So it's saying that this is 53 degrees up here. So it's saying that this piece is 53 degrees. So 180 degrees minus 53 degrees is going to be, well, (127 degrees). So it's telling us that this angle is 127 degrees. Okay. So there's different ways to do that. I wish I had a protractor with this thing. It might be hidden somewhere in here. If it is hidden, I'll show you how to use it. But you can measure angles using devices that exist, and measurement is super important in the world. I mean, if you want to go and get a job somewhere and you have to do any type of like factory work, there's going to be a lot of measurement involved. And I know people that have had to do like calculations on like gears and know the physics that's going on with particular devices or different machinery. But there's a few things that we can do with classifying angles, and you might have heard of this, but I just want to make sure that you remember this. So an acute angle looks kind of like this. Here's an example. And so whatever I measure this angle to be, it's going to be less than 90 degrees. The measure is going to be less than 90 degrees. Okay? And then you've got a right angle. In any right angle, right, you'll see the lines almost form an L. They're also called perpendicular lines, and you'll see this little box inside of them. It means that this measures exactly 90 degrees. For obtuse angles, you'll have something like this. And this measurement will measure between 90, so above 90, and 180 degrees. So it won't go over 180, and it won't go under 90 degrees, okay? So like we had earlier, we had an angle that was 127 degrees. So the left angle is acute. So it's less than 90 degrees, and this angle is obtuse. And then the last type of angle we have is a straight angle. And it's just a straight line. So if we measure from here to here, that's 180 degrees. Okay? And those are the different types of angles that you will encounter. And so we're going to do a few more of these statements and call it a day. Use the diagram to answer the following. It says angle CBJ is congruent to which one? So if I take a look here, I'm trying to find angles that are congruent. So I've got CBJ here. And if you take a look here, CBJ is going to be congruent to DHG. If you take a look, I've got a parallel line here. DF or DH is parallel to CA. Okay? And then B and G cuts right through these parallel lines at the horizontal. Okay? So that means that this angle is going to equal this angle. So I've got angle CBJ is congruent to angle DHG. So I'm going to write that. Angle CBJ is congruent, so it's an equal with a squiggly over it, DHG. And that's it. And then over here, it says FJH, okay? Now there's a theorem we're going to learn later, but if you take a look here, these three angles, it's corresponding to these three angles over here. So right now we're just trying to see which angles are congruent. So these three ticks are congruent to these three ticks. So FJH is going to be congruent to AJB. So I'm going to write that. Angle FJH is congruent to angle AJB. So that little L at the start just means angle. So AJB. And you can kind of see that with some of these. So I've got the measure of angle EFD, and it wants to know what JAB is. So since these two things are congruent, we know their measures. If two angles are congruent, their measures are also the same. So their measures are going to be equal. So EFD, if EFD, the measure of angle EFD is 75 degrees, then if I took a protractor with JAB, I better get 75 degrees. So I know the measure of angle JAB is 75 degrees. Okay. And then we've got the measure of angle GHF is equal to 130. So GHF, so that's an obtuse angle. They want to know what JBC is. So this angle here, JBC. And since they are two congruent angles, write these two ticks and these two ticks. This angle is congruent to this one. So I can say that the measure of angle JBC has to be 130. So I'll write that. All right. Got one more definition, and then we got some nice little algebra down here. So let's get this definition out of the way. It says angle bisector is a segment or line that divides an angle into congruent angles is what we want to say there. So I'll write this out. Definition, angle bisector. A segment, ray, or line that divides an angle into two congruent angles. Okay, so that is the definition. And then over here they want you to draw a picture, okay? So you've got KE is the angle bisector of angle K, okay? So let's draw angle K. So it's just some weird angle. So let's say this is angle K. And I'm going to get out my handy dandy measuring tool here. I'm just going to rotate this, and I want to know what this degree measure is. So I'm going to draw it parallel to that. So it's 63 degrees. So half of 63 is going to be 31.5. So I'm going to go down to 31, just a little over 31. And what you'll find is that let's undo that. That'll just about do the job, and it splits that angle into two different pieces. So what I'm saying is once we bisect an angle, that part is going to be congruent to that part, okay? Angle bisectors, and it said it was KE, so that's important, and it's a ray. It splits the angle into two equal or congruent pieces. Okay. Get rid of that little ruler. Okay. So now we get into the pretty algebra. Pretty algebra. And so they give us this diagram, and it spells math. So I'm just going to draw that. Woo. Nailed it. And it says ray AT is the angle bisector of angle MAH. Okay? So it says AT is the angle bisector of MAH. So MAH is this big angle here. And we just learned what angle bisector means. So let's take a look at that definition. It's a segment or ray, in this case it's a ray, or line, so in this case it's a ray, that divides an angle into two congruent angles. So congruent means that these two measures, these two angles are going to be the same measure. Okay, so we don't know what the measure is yet, but we know that they're going to be equal. And then it gives us some more information. It says the measure of angle MAT sorry, that MAT is equal to 60 degrees. And then it says the measure of angle TAH is equal to 4x plus 20. Okay? So what we've got is this piece is 4x plus 20, and we've got that this piece is 60 degrees. And the cool thing is, since they're equal, we can say that 60 is going to equal 4x plus 20. Okay? So that's something that we know. And over here, it's telling us to find x. Okay? So that's the key. Once we understand what we're doing with the geometry, once we understand our definitions, that's when we can start to find things out, start to kind of pick apart the relationships. So let's go ahead and do this problem. So I'm going to subtract 20 from both sides of this equation. I'm going to rewrite 4x on the left-hand side. So I've got 4x equals 60 minus 20 is 40. So if I divide both sides by 4, that gives us that x equals 10 degrees. Okay? Whatever x is, it's equaling 10 degrees. Everything else was in degree measures, so. And I lost it. Sorry about that. Okay. I've got another small little diagram over here that spells love. I guess these guys love math. And maybe I should try doing the ruler so it looks neater for you guys. I'm so sorry. This thing's very confused. So I'm going to do that and draw that. Come here. Come here. Okay. That is looking a lot prettier. Okay. And we had what, 60 something degrees? Yeah, so 31, just about. Do 32. Just kind of dip it down. There we go. Nailed it. No, I did not. That looks a little better. So I've got, this is L, this is O, and these are rays. This is E, and this is V. And then they're giving me some information. They're giving me some information over here. They're saying that LOV, so LOV, is congruent to V. LOV is congruent to VOE. Okay? So, angle LOV is congruent to angle VOE. And then they tell us that the measure of angle LOV is equal to the expression 7x minus 14. So I already have that this is equal to 7x minus 14. And then they tell us that the measure of angle VOE is equal to 3x plus 12. So this angle down here, it's congruent to that one. And the expression 3x plus 12 stands for its measure. And they want us to find x. That's the next goal. Well, I don't know x yet, but I know that x is involved in these expressions. And I know that these two things are congruent. And since these two things, angle LOV and angle VOE, are congruent, that means the measure of LOV is going to be equal to the measure of VOE. So I'm going to write that down. So the measure of angle LOV has to equal the measure of angle VOE, which means that 7x minus 14 equals 3x plus 12. Okay? So if this is the case, it just boils down to an algebraic expression. So I'm going to solve this for x, so I can subtract 3x from both sides of the equation. So I get 4x minus 14 equals 12. And then I can add 14 to both sides of that equation. So I get 26 equals 4x. And then I can take 4 and divide it on both sides, so x equals 26 over 4, which reduces to 13 over 2. And I can think about it as 6.5 units, or degrees. Yeah. So up here, the next thing that it's asking is it wants us to find the measure of angle LOV using that value of x. So we can do that. So the measure of angle LOV is equal to 7x minus 14. But since we know x is 6.5, we can solve this out. So I've got 7 times 6.5 minus 14. Okay? So we know that 7 times 6 is 42, and then 7 times a half is 3.5 minus 14. And that boils down to 45.5 minus 14, which is going to equal 34.5 degrees. Do that right? No, 31.5, my bad. 5 minus 4 is 1, so 31.5 degrees. So now that I know LOV, this is equal to 31.5 degrees. There's no reason for me to find VOE using the algebraic expression by substitution. I don't have to plug that number into this. I could if I want to, but since I know that these two things are congruent and I know that these two measures are equal, I know this, which is 31.5. And then I also know 31.5 plus 31.5 is going to come out to be, what, 63 degrees? No. Yeah, 63 degrees. Wasn't that what I measured it? It'd be really creepy if that's what I measured it. Yeah, that's really creepy. I had it right off the bat. Anywho, if there's any other one of these that you want me to work, I know that was a lot, but I'm just showing you kind of what's going on. You can classify angles. If it asks you to measure stuff, we might do that a little later. We don't have protractors yet, but some of these other homework sets are going to be easy. Right, EI is the angle bisector of MEK. Really similar problems. And then it's got some algebra review down here, so in case you forgot how to graph, we're going to be going over some of that. So that'll be good for your EOC when it's coming up. So I hope all this helps. And take it easy.